Good morning, students. Today let us see runtime environment. The major three topics of runtime environment are storage organization, stack allocation space, and heap management. Compiler must do the storage allocation and provide access to variables and data. Right. So the main memory is divided into 5 parts. Right. You have code, static, heap, free memory, and stack. Now in your storage organization, you have to manage and organize a logical address space. Okay, now here the maximum utilization of space at runtime and stack and heap is used. So already you are familiar with the static and dynamic allocation, right? Static means we cannot change, right? So dynamic allocation, it is in runtime. Now in our stack allocations of space, let us take the quicksort program. In the quicksort program, first we will get the input from the user, that is read array. Then we will invoke the quicksort program. Now according to the quicksort concept, we are supposed to partition the array into 2 parts. Then we will be calling quicksort for the first half and quicksort for the second half. Now this is the activation tree for the quicksort program. Let us consider that we have 9 elements and it starts from the location 1 to 9. Okay. Now the activation tree is given in the PPT. Now M is the main program, R stands for read array, Q stands for quicksort program, P stands for partition. We are calling quicksort 2 times, one for the left part and another for the right part. Now what is activation record? Now procedure calls and returns are usually managed by a runtime stack called the control stack. Each live activation has an activation record. The root of the activation tree is at the bottom of the stack. The current execution path specifies the content of the stack with the last activation where it has a record on the top of the stack. Now these are the important 7 fields of an activation record. Actual parameters, returned values, control link, access link, saved machine status, local data and temporaries. Right? Now if you see the function call, it is used in the stack and it is downward growing. So first we will be having the elements of the array, then main program, then we are calling the quicksort. That is whatever function call we are making, it is push. When the function is returning some value, it is popped. Now you all know function call and return, which is the calling sequence. That is values communicated between the caller and the callee. Now here fixed length items are actually used. We must locate the top of the stack pointer judicially, which is a common approach to have it point to the end of the fixed length fields. Now between the caller and the callee, the various responsibilities and the activation record is as given in the PPT. So we are supposed to save the parameters on the return value and we are supposed to maintain the flow of links. Right? So in the calling sequence, the caller evaluates the actual parameters. The caller stores the return address and the old value of top SP into the callee's activation record. The callee saves the register values and other status information. The callee initializes its local data and begins execution. Similarly, the corresponding return sequence is also maintained and it is restored in the respective temporaries and the registers. Now, variable length data on the stack. Actually, the data what we are going to use, it is of variable length. Right? So, to allocate objects, arrays or other structures of unknown size, variable length data on the stack is used. Okay. Now access to dynamically allocated arrays. Now during the function call by the caller and the callee, while you are maintaining the activation record, we are supposed to maintain the values of the array, various movement of the pointers and the control link. The next important topic is heap management. Okay, let us continue heap management in the next class.